Hey, thanks for joining me. I'm Andrew Axum with Axum Outdoor Adventure, Axeman on the slingshot form. And as you can probably tell, it's really windy out here today. We actually have a wind advisory in place in this area. I'm actually holding my tripod down right now to keep my camera from blowing over. We actually have a wind advisory going on until about 8 p.m. tonight. The current ambient temperature out here is 66 degrees, and I was out here shooting earlier, and as I was holding a shot, I could feel the wind really making my bands shiver in the wind as I held them back, and it made me start thinking about what I've always heard, which is that the longer you hold the shot, especially in windier or cooler temperatures, that wind will dissipate some of the heat that's held in your bands and reduce the speeds and the power of your shot. But I've also heard the theory that heat that's dissipated is just a byproduct of the energy and not actually the energy itself, and so that dissipation of the heat will not affect the retraction of the bands and the speeds and power of the shot. And I thought to myself, what better day to come out here and test both of those theories than on a really windy, blustery day. I have 3 different size bands I'm going to test. The first one is a 0.4 green apple from Precise. I'm going to shoot some BBs through this. First, I'm going to take the temperature at all 4 contact points, the frame side and the pouch side of the band, and just see what it is out here right now. So 66.1 on one of the frame ends, and a 66.0 on the other frame side. Let's check the pouch side. 64.7 and a 64.9. So about a degree cooler on the pouch end than it is on the frame end, which is interesting because these are tapered at a 12 to 10 millimeter taper, so there is a little less material on the pouch end, so that could account for why the temperature is dropping more drastically on the smaller end. There's less material there, but I'm going to go ahead and fire 5 shots through the Crony, just kind of at a rapid succession rate, as rapid as I can with BBs, and then I'm going to take 5 more shots where I hold the shot for about 5 seconds and just see how the speeds compare to taking the shots quicker to taking the shots at a more protracted held out rate, and see what it does to the speeds. Alright, I'm going to take 5 shots through the Crony with some BBs without holding the shot. I'll call the speeds out and we'll see what the speeds are without holding the shot. .286.3. .288.6. .287.6. 286.0. 286.0. 1, 2, 3, 4. 275.8. 1, 2, 3, 4, 5. 274.8. 1, 2. 278.8. 277.4. 279.1. The 0.4 seemed to drop the speeds down around 6 to 10 feet per second slower. So it does seem like there's some validity to the argument against holding your shot longer, at least with the 0.4. Let's go ahead and check the 0.5, see if we'll get the same results. Okay, so the second band we're going to test is a Sniper Sling Yellow 0.5 cut at a 20 to 12 taper. I'm going to shoot 8mm with these, but let's go ahead and take the temperature again at the 4 contact points. So 66.7 at the frame end, 65.1 at the other frame end. So I don't know if it was catching a little more wind or something, but a little cooler on that side. Let's check the pouch end. 65.1 and 64.8. So this band is a little cooler than this one. I don't know if it was just the way it was laying or the wind blowing across it. Okay, same deal. We're going to go ahead and take 5 shots through the crony, not holding the shot for very long. I'll call out the speeds, then I'll take 5 more, holding the shot for about 5 seconds each. We'll compare the speeds, see what it does. .224.0. 225.6. 238.4. 234.8. 233.8. All right, again, I'm going to take the temperature here of these real quick. 66.0, 65.8, 64.9, and 64.9. So interestingly enough to me, it seems that whatever heat that does build up in here dissipates fairly quickly, because I know there's heat that builds up. I can feel it whenever I pull it and have it close to my face. I can feel the heat, so it dissipates relatively quickly once it retracts. But the interesting part to me is that the ends that are close to the pouch, the ends of the band that have less material, are consistently lower in temperature than the ends with more material. So that's just interesting to me. Okay, again, same thing. 5 shots with the 0.5 Sniper Sling. It's 20 to 12 taper. I'm going to take these 5 shots through the crony, but I'm going to hold them quite a bit longer, see what that does to the speeds. 212.8. 224.0. 212.5. 232.2. 224.6. That brings us to the last band, which is the Sniper Sling 0.6 black at a 20 to 12 taper. By the way, all 3 of these bands are cut at 5 1/4 active band length, just to get the most speeds out of them that I can. So I'm going to take the temperature of this again at the 4 connection points. And so 66.2 at the frame end, 66.3 at the other frame end, 64.8, and 64.7 at the pouch end. So same thing. So interestingly enough, again, the smaller end, the tapered end, is holding less heat. So same drill. We'll go ahead and take 5 shots through the crony without holding the shots. I'll call out the speeds, take 5 more holding the shots, and then wow, I think my cover just blew off my grill. So I'll get that in a minute. 5 shots through the crony without holding them, and I'll take 5 more holding them. $278.8. This black sniper sling stuff, it's awesome. $284.7. $283.7. $279.4. $260.1. 65.2 on the frame end, 66.2 on the frame end, 64.6 on the pouch, and 64.4 on the pouch. So consistently, the thinner tapered ends are holding in less ambient heat. That's just interesting to me. But I'm going to go ahead and take 5 shots, holding the shot a little longer now. $274.8. $265.3. Gotta go fix my can. $274.5. $259.7. Can fell again, but I'm just going to take one last shot through the crony without worrying about the can. $277.1. Well, this has been a fun experiment to do, and I love to kind of break down everyday scenarios, kind of collect some of the data and look at it, analyze it, see what the numbers are telling us. In this scenario, in every example, the average speeds of the held shots dropped over the average speeds of the non-held shots. For the 0.4 band, it dropped 9.1 feet per second slower. For the 0.5 bands, it dropped exactly 10 feet per second slower. And for the 0.6, it dropped 7.06 feet per second slower. When you combine that with the fact that in every scenario, the thinner sides of the tapered bands held less thermal energy than the thicker sides, then it kind of lends credence to the idea, at least in my mind, that the more rubber or latex material you have, the less heat dissipation you're going to have in general. And especially when you're holding it, I feel like the thinner latex is going to dissipate the heat quicker than the thicker rubber. I think that also was kind of an example of that was when we weren't even stretching the bands, when we were just letting them lay there and collect the ambient temperature. The thicker ends of the bands with more material almost always seem to be 1 to 2 degrees higher than the thinner end of the bands. And there was no direct sunlight, so this was all in an overcast condition. And I feel like that the wind that was present out there was cooling off the thinner end of the bands a little bit quicker. So kind of along the same lines, when you're holding those bands out and you're stretching them thinner, I think the ambient temperature, if it's cold enough, or at least the wind chill on a day like today, is going to help lower the temperatures enough that you're going to see the speeds drop down as well. So this has been a rather unscientific experiment on my part, but I've had a lot of fun doing it, and I feel like it's answered some questions in my mind. I hope you've enjoyed it, and I hope it's been fun and informative to watch. If you do enjoy these videos, don't forget to subscribe to us. Also, don't forget to give us a like, and remember to hit that bell icon so you can get alerts anytime we put out new content. Thanks for watching.